Hello everyone, myself K. Mohammad Fari, AIML department, third year. Here I am going to present my assignment 1 of course Artificial Intelligence. The topic is Evaluation and Design Solution for Decision Making in Self-Driving Car under Uncertainty using Bayesian Reasoning, guided by Shilpa RN, Assistant Professor of AIML, GM University. Introduction. Self-driving car or autonomous car must operate safely in complex and constantly changing environment. However, this car faces uncertainty because of many reasons like sensor noise, blocked and hidden objects, and unpredictable human behavior on road. To handle this uncertainty situation, we use Bayesian reasoning, which is the mathematical method to measure uncertainty and update belief based on new information. This helps the car to make decision drive risk awareness and adaptive decision. So overall, Bayesian reasoning allows a self-driving car to make decision not just based on what it sees, but also on how confident it is about what it sees. Next, Bayesian reasoning in autonomous vehicles. Bayesian reasoning in autonomous vehicle based on Bayesian theorem, which means we start with a prior belief and then update it when we get new evidence. For example, if the car camera detects something ahead, it first assumes it could be a signpost. That's the prior. Then it checks the new sensor data. That's the evidence. And updates its belief using Bayesian rules to find out it most likely is the posterior beliefs. This approach is used in many parts of self-driving system. Perception, understanding what around the car. Localization, figuring out where the car is on the map. Decision making, choose what action to take next. The key tools that makes these possible are Kalman filters, particle filters, Bayesian network, all which helps to vehicle continuous updates its understanding on the environment. Next is challenges due to uncertainty in sensor data. One of the biggest problem for autonomous vehicle is sensor uncertainty. Sensors like camera and radar can sometimes give noisy or conflict data. For example, weather and light condition like fog or rain can reduce sensor accuracy. Uh, Accumulation such as vehicle blocking and blocking can hide important details. Conflicts between sensor happens when one sensor detects something and another doesn't. Real-time processing is difficult because Bayesian update requires a lot of computational power. So because of these challenges, it became hard to maintain accurate and consistency data, which affects how safety the car make decisions. Next is safety risk from wrong prediction estimation. If the car makes wrong prediction estimation, it can lead to serious safety issues. For example, misclassification objects. Thinking and sign point is a person overconfidence. When the system is too sure about something that actually wrong. Ignoring rare but risky events like a child suddenly running across the street. Inconsistency sensor fusion where mixed up data causes the car to behave unpredictably. Next is a small mistake over time can build up and affect the car over control. So wrong prediction estimation doesn't just reduces performance, it can actually lead to accident. That's why uncertainty must be handled carefully. Next is evaluation of mitigation strategy. To overall uncertainty, we can use several mitigation strategies. Sensor fusion, combine data from multiple sensors to reduce noise and improve accuracy. Next is using backup sensor so it one fail another can take over. Next is Bayesian filtering, predicting and correcting motion data to make decisions smoother. Stimulation testing, testing the car in virtual environment to find edge cases and improve model performance. Uh, Next is proposed framework and matrices. Uh, First is in framework component, Bayesian interference layer, models that uncertainty in sensor reading. Decision model chooses the safest action based on risk. Learning layer update the system continuously as new data comes in. Feedback loop improve decision making through testing and learning from past result. Next is matrices. Here we use reliability score, how constantly the car performs safely. Mean uncertainty error, how close the predicted uncertainty is in the real error. Safety probability index, measure safety in risky situation. Calibration error, check how well the system confidence matches actual output. Together this framework and this matrices helps to autonomous vehicle more reliable and intelligent. Last is conclusion. Uh, Here Bayesian reasoning is a powerful approach that helps to self-driving car to make self and reliable decision in uncertainty real world environment. It works by combining probability, data fusion and learning, allowing the car to adopt the actual intelligence. By applying Bayesian method, we can better handle sensor noise, unpredictable condition and uncertain events. For future work, researching and focusing on deep Bayesian models and adapting uncertainty estimation. These can help the system become even smarter and safer over time. So, Bayesian reasoning truly support the goals of building tr- truthworthy, risk-aware, and dependable autonomous vehicle. Thank you.